Data cleaning. Data cleaning is the next process after data collection. It is the process of preparing our data for analysis. In this process, we identify and remove records from a dataset or table. This is done to find out unfinished, unreliable, and inaccurate or non-relevant data in our dataset. So what we are going to do with this is we are going to restore the data or remodel it or remove the dirty or crude data from the dataset. After cleaning, it will be uniform and it will be relational with other datasets in operation. IBM Data Analytics quotes that 80% of a data scientist's valuable time is spent simply finding, cleansing, and organizing data, leaving only 20% to perform the actual analysis. The common reasons for discrepancies in a dataset may be as follows. User entry mistakes. A user may enter a data wrongly. Corruption in storage or transmission. The third one may be various data dictionary description of similar items in various stores. A same product may be quoted differently by different companies, and this may also create discrepancies in the dataset. The common sources of missing values in a dataset could be of the following reasons. The user would have forgotten to fill a field of data, or the data would have been lost while transferring from a legacy database, or it could be a programming error, or the user would purposely choose not to fill a field thinking that it would not affect the results. To sum up, the sources to be considered for a data cleanup are missing data, outliers, bad data and duplicates, irrelevant features, and standardization. Let us consider each one of them in detail. Let us analyze the necessity of data cleaning using a sample dataset. This dataset on screen has 4 features: state number, state name, number of bedrooms, and own occupied. And we find certain redundancy in the data. There are places wherein the data is not entered. There are places where the data is entered wrongly. In the state name, we have a value called Putnam, which is not a state name. And we also have a value called 12, which is not expected. Instead, it should be either yes or no. And there's also a case wherein not available is given in 4 different formats: n/a in small case, NA in caps, NA in small case, and we also have a dashed column. So all this represents not available, which again has to be standardized. So these are the problems with this data set, and this has to be cleaned in order to get a better result. Missing data. A dataset can be loaded into the Pandas library using the method pd.read_csv. By default, when you import the data, the missing data values are either classified as NaN or none. If you find any missing values in your dataset, you can perform any of the 3 tasks on it. First one is to leave it as it is. Second one is to fill the missing values, or the third one is to drop them. We will check the implementation of Python code. The first one is to check for NaNs, not a number. For this, we use the Pandas library and we use the method isNull of the object. This detects both NaN and none. In order to replace missing data, we use the NumPy library and we use the method df.replace. It has 2 parameters. The first one is the null value and the second one is the value which is going to replace the null value. In order to drop the missing data, we use the NumPy library and we use the method df.dropNA. We set the access and we set the parameter of how to any. This returns your data frame where any data points containing not a numbers have to be removed. Now let us work out on outliers. In this case, I'll take the range as 2 to 98 as my focused area of concern. So anything above 98 and anything below 2 is going to be my outlier. So when I set I have a function which sets upper limit is equal to 98 and lower limit is going to be 2 using the log_error.values function, and I'm going to filter anything above that is going to be my outlier and anything below that is also going to be my outlier. Bad data and duplicates. I take a case where gender is my feature. There are 2 possible values, one is male and other one is female. Anything other than this is going to be considered as a bad data. In this example, I have a case wherein I have an option which is male, I have an option which is female, and I have another value which is 67.3, which is neither male nor female. So now this data has to be considered. So manually what I can do is I can map the value of this to a particular gender. So in this case I have mapped the value to female. So this is how you eradicate bad data in a data set. Irrelevant features. Irrelevant features are features in a data set which has more than 90% of the values to be not a number or none. It makes no point in using these values because most of the values are empty. So in order to drop a feature, we use the NumPy library and we use the method drop. So we have two parameters here. One is the name of the variable and the next one is the axis. Standardization. When users enter data into a data set, they may follow different formats for data entry. Some may enter all the data in small case, some may enter all the data in caps, some may even prefer entering the first letter to be in caps, and some may have typographical errors. In order to make the whole string into lowercase, we use the lower method, and in order to capitalize it, we use the capitalize method. Through this, we can either make all the data in the data set to be either in uppercase or lowercase. If there are typographic errors in the data set, we use the mapping functions. We identify which are the errors in data entry and we map that with the mapping function. Here, the word make is mapped with male and female is mapped with female. Through this, we can standardize the data into a single format. So to sum up, these 5 types of data has to be cleaned up, and after these steps, the data is ideal for further future processing.